In this video, we are going to discuss some few reactions on alkynes, and then we are not going to do more of mechanisms. We are just going to go through what you should do when you see a particular reagent. What am I going to do? What am I going to do to the triple bond when I see this reagent? Okay, so before we begin, I would like us to go through some simple reaction that we did with the alkenes in our previous video that we did. Now, with the alkenes, when we are having a double bond and then you bring in, say, H plus and then water, what happens is that when you bring H plus and water and you have a double bond, say this double bond, H plus in water tends to add H and then OH. This is what we did for the previous one. And then H comes and then carbocation will form on the other side, then the OH comes. But what if you have a triple bond? Do we also get a triple bond like this? Do we also get H and then OH like this? That's what we are going to do here. This won't happen, or even when it happens, it can be isolated. It is more of an intermediate that is being formed. Okay, so this is more of an intermediate that is being formed. Now, when you add H and then H in water, H plus in water to a triple bond, this is what forms. You get an enol. When you add H and then H in water, or in HJSO4, what happens is that there is an enol formation. That's an intermediate, and then this intermediate, it forms again. The OH hydrogen electrons moves inside, then forms this double bond by a base. The base comes and then deprotonates or takes this hydrogen. Then the double bond, and then the base comes in to pick this hydrogen. Then the bond swings inside to form an O double bond, where this double bond, that's the alkane over there, also goes out to pick an hydrogen, or this can first pick the hydrogen, then for this to move in. So, but what you have to take note is that there is a formation of an enol, and then it moves on to form a C double bond O. That's a carbonyl. So when you add this, instead of forming an H and an OH, it forms rather a carbonyl with an H. Let's take note. So this is what I brought. Then take note, when it's for alkene, we just add an H and then an OH. But when it's for alkyne, we add an H and then what? A double bond. That's a carbonyl. Okay. So we have examples that we are going to talk on this particular hydration of alkynes. Now, let's go through these three reactions. Now we have this particular alkyne, which is a terminal alkyne. So as you can see, when we have HCl reacting with this alkyne, what happens? If it would have been, say, if it would have been a double bond, what we get is an H and then a Cl. But over here, the same thing is going to happen, but the H and the Cl will be added twice. So we have this particular triple bond. We have this particular triple bond here. We add two of this. So the first one, we are going to add two of HCl, right? So the first one is, the first HCl comes in, but it also follows Markovnikov. As I said, Markovnikov says that the hydrogen is going to bond to the carbon, which is less substituted, for a carbocation to be formed in order for the X or the chlorine or the halogen to also come inside, to also come and bond to the carbocation. Okay, so when you have this, what the first reaction that we are going to get is that this is going to form. The hydrogen will come here. So as you can see, so that a carbocation forms here, then the chlorine comes in like that. Then the next one will also come again, where it's also follow Markovnikov. So HCl will come again. Then the second hydrogen will come here. So this, see, the second hydrogen is the first hydrogen. So let me put it here rather. So the second hydrogen will come here. This is the first hydrogen. The second hydrogen also comes in. Then the second chlorine will also come in like that. So mostly with addition of HX, where the X can be a chlorine, a bromine, or iodine, it mostly forms a geminal halide. A geminal halide, where when we talk about a geminal halide, a carbon containing two halides on it. So we have, say, this compound. This carbon will be having this particular halides both on that single carbon like this. This is called a geminal halide. And we also have a vicinal halide, but mostly this one forms a geminal halide. A vicinal halide is when the two adjacent carbons contain a chlorine. The two adjacent carbons each contain a halogen. So the halogens are on the two adjacent carbons. That's the vicinal halide. So in this particular reaction, we are going to get C, then H comes here, H comes here, then here to Cl comes here, Cl comes. This is what we are going to get. Now, these two we are going to add. So when you see this reaction, H in water and then HgSO4, it has its mechanism there. But what you have to know is that it has what? A carbonyl. It has an OH and then an H, but the OH, which is in the inner form, it adds an OH and then an H to a double bond, where the OH now forms a carbonyl, just as we did earlier. So here we are going to get a compound like C, double bond O, then C, H, then the new H that we are having will come. So it's more of 2H is going to come to this side, then the carbonyl will be formed over there. Now the last one, to this one also adds an H and an OH. When you remember, with the addition of alkanes, when we see hydroboration, there is addition of H and an OH. Likewise, this one too is going to be C, but the OH in triple bond is later turned into a carbonyl. So we're going to get this. So as you can see, this is actually forming an aldehyde. Take note, hydroboration always follows anti-Markovnikov. It doesn't follow Markovnikov. So instead of the H to come here for the OH, instead of the H to come here for the carbocation to form here, no, the H rather comes here for the carbocation to form here, for the OH to come here. Then the carbonyl is formed here. You see, that's why this is forming an aldehyde. But this one went into form what? A ketone. Okay. Now the next reaction that we are also having is the sign addition. The addition of hydrogens to a triple bond. Now these two reactions actually add hydrogens to a triple bond. They add two hydrogens like that to a triple bond to get a double bond. But one adds it in a sign addition and the other adds it in a trans addition. So when we have an Ni2b P2, that's mostly called the Lineless catalyst. The Lineless catalyst, or others also call it the poisonous catalyst. When this reacts with a triple bond, what happens is that it forms a sign addition. So these two bonds forms an alkane. Now let's say this R, this R. So R and R. There are two hydrogens that are added in the same side. So it can be a dash or it can also be a wedge. But when it comes to lithium or sodium in liquid ammonia, this is also called the dissolving metal reaction, where we have metals, specifically lithium and sodium, that is being dissolved in an ammonia liquid. It forms the trans one. So C, this, then R, that. So you can make it one. You can say make one like this and then one like that, or immediately you just turn it like this. You can just bring your lines, then it will be done. So this is the trans addition and then there's the sign addition. Take note when this is being seen in a particular reaction, what we should do. Now the next reaction that we are having is also the alkyne anion being formed and then reacted with an alkyl halide. Now, when we have an alkyne, say we have this particular alkyne, mostly the terminal alkynes, what happens is that when this is reacted with sodium in ammonia, or it can be, it's mostly called NH2. NH2 is sodium ammonia or sudanamide. It's mostly called sudanamide. So when it reacts with this, since this hydrogen is very, very, very acidic, can be lost easily. So we get our alkyne anion being formed from that when we react this with the sudanamide. So what forms is this? Then the sodium gas comes here. Then we have our ammonia being formed. So this what mostly we get, and then this can be used in a lot of reactions. This can be used in, you can use it subsequently to react with any alkyl halide, and then this is going to take the alkyl group, then form a chain lengthening. So that's one way of forming a chain lengthening of an alkyne. So we have one reaction here. So this reaction, the first one is going to give us the alkyne anion being formed. So the first one is going to give us the alkyne anion that is being formed. Then the second one, the alkyne anion being reacted with an alkyl bromide. This is going to take that, and this takes everything away. So we are going to form a chain lengthening. Now it is bonded to the R. So this is what we get. So let's take note. When we see a sudanamide, it just take away this hydrogen, then it can react with anything. So when it's an alkyl halide, it takes the alkyl group, then we form a chain length. Let's go through one simple example. So this can be a simple example, it can also be a complex example, as you can see. So we are having three reactions occurring at the same time. Try and let's see what we get. Now, when we're having a reaction like this, we have to go step by step. The first reaction, you have to consider the first reaction first, because we are having two functional groups here. But the first reaction will prefer to react with this. That's the sudanamide in liquid ammonia. It will prefer to react with the alkyne. So it reacts with the alkyne, then it deprotonates the hydrogen. It forms what? An alkyne anion. So what we are going to get in the first reaction is this. Get this alkyne. This is the first reaction, what it gives us. So that's what we are going to get after reacting with the sudanamide. Now the second reaction is with an ethyl bromide. It reacts with an ethyl bromide. This goes in to pick the ethyl away from the bromide. So we are going to get the second one. This is what we are going to get over there. The triple bond is here. Sorry, I made a mistake here. It should be that way rather. It's 1, 2, 3. Yes, so it should be that way rather. But let's focus on this side. So it goes in, then it picks this ethyl away from the bromide. Okay. Now we also have a second reaction that is coming. So this can also be drawn as, you can draw this one to us. 1, 2. It's this. So you can write it this way, right? Yes. Now the last reaction, the third one, we are going to react it with a poisonous catalyst or a Alkynes catalyst. So reacting with a Alkynes catalyst is going to form an alkane, a double bond. So what we are going to get is that before. So let's count and see. 1 2 3 4 5 6 7 8 9 10. So the 9 and 10 position are for the double bond. So 1 2 3 4 5 6 7 8 9 and 10 are for the double bond. But these double bonds react with a Linus catalyst, and then they are sign addition. So since it's a sign addition, we make sure that we show it. So it comes like that. This is how it will be. Or you can make both of them dash, or you make both of them wedge. This is how the product will be. Anything other than this is wrong. So we get our final product as 1 2 3 4 5 6 7 8 9 9 and 10 are having a double bond. Then we bring our ethyl. So this is the final product that we get for our reaction. Thank you very much for watching this video.